This lesson is an introduction to the Pythagorean theorem. The Pythagorean theorem applies to right triangles only. Right triangles are triangles that include a right angle. Before we really get into the Pythagorean theorem, we're going to go over the parts of a right triangle. So in a right triangle, the two sides adjacent to or touching the right angle are known as the legs, and they're represented by A and B. The side that is opposite from the right angle or across from the right angle is called the hypotenuse. And this is represented by C. The hypotenuse is always going to be the longest side of the right triangle. So the legs are the two shorter sides. The hypotenuse is always the longest side. The Pythagorean theorem is a theorem and a formula that tells us how the side lengths of right triangles are related. So in any right triangle, the square of the hypotenuse, or C squared, is equal to the sum of the squares of the other two sides, or the legs. This relationship can be represented like this. The square of A, or A squared, plus the square of B, or B squared, has to be equal to the square of C, or C squared. So square the legs, add them together, and that has to equal the square of the hypotenuse. Now we're going to look at some examples for labeling A, B, and C. So remember that the sides that touch the right angle or come together to form the right angle are always going to be A and B. The side across from the right angle is always going to be C. So looking for what touches the right angle and what's across from the right angle. What touches the right angle and what's across from the right angle. The side that you pick to be A and the side that you pick to be B don't really matter. The legs are interchangeable. Now we're going to look at how to use the Pythagorean theorem to find missing sides of a right triangle. So first we're going to label the legs and the hypotenuse, or A, B, and C. And that's going to help us figure out which side is missing. We're going to substitute the known values into the Pythagorean theorem. And we're going to solve for the missing variable. Remember, the Pythagorean theorem is A squared plus B squared equals C squared. Now, one thing that we're going to look at, and just a trick I want you to remember, is that if we're solving for C, we're going to add. If we're solving for A or B, we're going to subtract. And we'll look at that a little more closely in a minute. So for example number 1, I've got 3, 4, and a blank side. When I look at 3 and 4, those sides come together to form this right angle. So I know that they're A and B. So the missing side must be C. So when I look at the Pythagorean theorem, I'm going to substitute those values in. So I know that the legs are 3 and 4. So 3 squared plus 4 squared equals C squared. Well, that's 9 plus 16. Or 25 equals C squared. Now the opposite of squaring something is taking the square root. So to get rid of C squared and make it just C, I'm going to take the square root of both sides. The square root of 25 is 5. So C in this case would be 5, or the hypotenuse would be 5. Now I want you to try example 2 and 3 on your own. You can use a calculator to help you with this, and feel free to consult a neighbor if needed. Looking at example 2, again, the sides that I've been given come together to form that right angle, or they both touch the right angle. So I know that I've got A and B. So A squared plus B squared equals C squared. So 24 squared is 576. 7 squared is 49. So 576 plus 49 is going to give me 625. When I take the square root of both sides, I get that C equals 25, because 25 squared is 625. So the square root of 625 is 25. Now looking at example 3, again, these two sides come together to form the right angle. They touch the right angle, so I know they're A and B. So A squared plus B squared equals C squared. So 7 squared plus 12 squared has to equal C squared. So that's 49 plus 144 equals C squared. When I find the sum of the squares of A and B, or 49 plus 144, that's 193. Now I know that's not a perfect square, so it's probably going to give me a decimal. It's important to look at the directions, which told me to round to the nearest tenth. So I'm going to take the square root of both sides. When I put that in my calculator, I get 13.8924. Now it says to round to the nearest tenth, which is that first decimal place. That 9 is going to make that 8 go up 1. So C is approximately 13.9. So we just looked at what to do when you're missing the hypotenuse and solving for the hypotenuse. Now we're going to look at what to do when you're missing one of the legs in a right triangle. So let's look at example number 4. The two sides that come together to form the right angle are the legs. The side across from the right angle is the hypotenuse, or C. So I've been given one of the legs and the hypotenuse. So I know that A squared plus B squared equals C squared. So 5 squared plus B squared equals C squared, or 13 squared. So this is 25 plus B squared equals 169. Now, I have to solve this just like I would solve a regular equation. I'm solving for B, which means that I have to move everything to the other side. To do that, I'm going to subtract 25, and I get B squared equals 144. So essentially what I did was I took C squared and subtracted A squared. So C squared minus A squared equals B squared. The last thing I have to do is take the square root of both sides to get B by itself. So B equals 12. So the legs of this right triangle are 5 and 12, and the hypotenuse is 13. Now I want you to give example 5 and 6 a go on your own. Remember that you can use a calculator, you can turn to a neighbor if necessary, and to round to the nearest tenth if you get a decimal answer. Looking at problem number 5, the sides that come together to form the right angle are the legs. The side across is the hypotenuse. So I've been given a leg and a hypotenuse. So I know that when I'm finding a leg, I'm going to subtract. So C squared minus A squared equals B squared. So 10 squared minus 6 squared equals B squared. And all I'm doing is cutting out a step when I am subtracting to start with. So that's 100 minus 36 equals B squared. So 64 equals B squared. My last step is going to be to take the square root of both sides to get B by itself. So B, or the other leg of the triangle, is going to equal 8 yards. In example 6, again, I'm looking at that right angle. The side across from it is C, so I know I've been given the hypotenuse, and I've been given one of the legs. So I'm going to do C squared minus A squared equals B squared. So 24 squared minus 16 squared is going to give me B squared. Using my calculator, I know that 24 squared is 576. 16 squared is 256. When I subtract, I get 320. And I know that 320 is not a perfect square, which means I'm going to get a decimal answer, so I'm going to round to the nearest tenth like the directions told me to when I take the square root of both sides. When I put this in my calculator, I get that the square root of 320 is 17.8885. Rounding to the nearest tenth, that 8 is going to make that first 8 go up. So B is approximately 17.9 miles. The next thing we're going to do is look at some word problems. The first thing you should do when you have a word problem for the Pythagorean theorem is to draw a picture or a diagram. They don't have to be incredibly realistic, but you should be able to tell what's what and assign your measurements. So number 7 says a rectangular pool at Andy's gym measures 25 meters by 50 meters. How many meters would Andy need to swim in order to swim diagonally across the pool? So he's going to swim diagonally. So I know that a rectangle is made up of 4 right angles. So when I split that rectangle diagonally, what I've done is I've created a right triangle. Now, if I look at this right triangle, what I've been given are the 2 sides that touch to make the right angle. What I'm missing is the diagonal. So I'm missing C, and I've been given A and B. Since I'm solving for the hypotenuse, I'm just going to do the Pythagorean theorem as normal. So 25 squared plus 50 squared equals C squared. 25 squared is 625. 50 squared is 2,500. When I add them up, we get 3,125 equals C squared. To solve for C, I take the square root of both sides, and I get that C is approximately 55.9. So he would have to swim approximately 55.9 meters to swim diagonally across the pool. Now let's look at problem number 8. A pole vaulter rests a 17-foot pole against a wall. So if I have the ground, the wall, and the pole being rested against the wall. If the top of the pole hits the wall 14 feet above the ground, how far from the wall is the bottom of the pole? Here it looks like I'm missing 2 measurements, but don't forget that they said that the pole is 17 feet long. So what I have is the side across from the right angle and one of the shorter sides that touches the right angle. So I've got a leg and I've got the hypotenuse. So since I'm solving for a leg, I'm going to subtract. C squared minus A squared equals B squared. So 17 squared minus 14 squared equals B squared. 17 squared is 289. And 14 squared is 196. When I subtract, I get 93. And my last step, as always, is to take the square root of both sides. I know that 93 is not a perfect square, so it's going to give me a decimal answer, and I'm going to round it to the nearest tenth. I get 9.643. That 4 is going to leave that 6 how it is. So B is approximately 9.6. So it would be 9.6 feet away from the bottom of the wall.